Greetings, fellow mathematicians. Let's investigate the Year 5 scope and sequence. Page 1 contains a whole year overview of the concepts taught in Year 5. A green arrow shows the links between essential related concepts. An orange arrow shows the essential prerequisite for further concepts. The concept name and level is the name and level used at a learning place, a teaching place. The abbreviated text identifies the Australian curriculum and New South Wales syllabus content descriptions. As you can see, the focus of number and algebra in Year 5 is on extending multiplicative place value to multiplying and dividing by 10, 100 and 1,000 to thousandths. Students extend their understanding of fractions to explain the role of the vinculum, and using this understanding to divide remainders to create a fraction. They add and subtract fractions with the same denominator. They investigate highest common factors using their understanding of divisibility tests, and then use this understanding to simplify division calculations. In measurement and geometry, students begin to measure and construct angles in degrees using a protractor, and they use this understanding to investigate the angle and side properties of two-dimensional shapes, enlarging the shapes to make similar shapes, and to investigate rotational symmetry. They use their understanding of multiplicative place value to thousandths to convert between metric units of measurement of length. They use their understanding of the metric units of measurement for length to investigate hectares and square kilometres. Students investigate volume and capacity in cubic metres and mass in metric tonnes, using their understanding of multiplicative place value to convert between metric units of mass. Students also compare the metric system and imperial systems for length, area, volume and capacity, and mass. They investigate properties of prisms and pyramids, and conduct chance experiments describing probabilities using fractions, and create graphs and tables. Pages 2 to 5 contain a term-by-term sequence of concepts taught in Year 5. Each term presents essential prior concepts from the previous year and terms. Each term's scope and sequence is divided into weeks, with essential prior concepts being taught first and essential related concepts being taught together. For example, multiplicative place value of decimals to hundredths by multiplying and dividing by 10, 100 and 1,000, and converting between metric units of measurement are all taught in the same time frame. These are prior knowledge needed to investigate the role of the vinculum and side and angle properties of two-dimensional shapes. The weeks that new concepts are introduced are arbitrarily selected. Your teacher judgment will be vital to deciding when is an appropriate time for your students and how much time to spend continuing to investigate prior concepts. Some students may be ready to investigate new concepts before others. This will require differentiation. For example, you want to begin teaching multiplicative place value of decimals to hundredths by multiplying and dividing by 10, 100 and 1,000. But A, 2 students cannot yet explain multiplicative place value of whole numbers, and B, 3 students cannot yet explain multiplicative place value to tenths, and C, 4 students cannot yet explain multiplicative place value to hundredths. All students can engage in the explicit teaching segment of the lesson that includes A, multiplicative place value of whole numbers, B, multiplicative place value to tenths, C, multiplicative place value to hundredths, and multiplicative place value of decimals to hundredths by multiplying and dividing by 10, 100 and 1,000. What does differentiation using these sample levels of understanding look like? The explicit teaching segment of the lesson covers the levels of concepts that students will be investigating. Begin the explicit teaching using questioning at the lowest level of understanding, then proceeding through other levels. Using a different colour for each level allows students to identify and name their level by colour. For example, A. Multiplicative place value of whole numbers, B. Multiplicative place value to tenths, C. Multiplicative place value to hundredths, and multiplicative place value of decimals to hundredths by multiplying and dividing by 10, 100 and 1000. This explicit teaching segment of the lesson literally takes 10 to 15 minutes. The bulk of the lesson time is spent with children investigating at just beyond their current level of understanding. What does differentiation using these sample levels of understanding look like in the investigation and reflection segment? Students do not need to sit with a teacher or another adult just because they are learning at a different pace. As long as they are investigating a concept at just beyond their current level of understanding, every child can investigate independently. All students can sit next to a child who is investigating at a different level. For example, A. Multiplicative place value of whole numbers, B. Multiplicative place value to tenths, C. Multiplicative place value to hundredths, and multiplicative place value of decimals to hundredths by multiplying and dividing by 10, 100 and 1000. Children may be directed to their level by the teacher, or children look at the levels recorded on the board during explicit teaching. If one level is too easy, they look at the next level. If the next level is too easy, they look at the next level. They continue until they find the level that is just beyond their current understanding. Children use cards to generate numbers to investigate at their level, then the next level. They pause occasionally to explain their understanding to the child sitting next to them, regardless of that child's level of understanding. What does differentiation using these sample levels of understanding look like in problem solving? Children use their current understanding to investigate solving a problem. Problem solving provides opportunities for children to apply their developing understanding and further develops their understanding. Problems can be easily differentiated to suit the levels of understanding of your students. Children may be directed to the level of the problem to solve by the teacher, or children could look at the levels of the problem and select the level that is at their current level of understanding. If one level of the problem is too easy, they look at the next level. If the next level is too easy, they look at the next level until they find and solve the problem at their current understanding. Observing and questioning children as they investigate, listening as they explain their understanding to a friend, and collecting books at the end of each lesson all provide immediate assessment data which can then be used to inform future teaching to meet the specific learning needs of the children. The children's talk, writing and actions all display their current level of understanding. Thus, teaching and formative assessment are indivisible. But how do you initially know each child's current level of understanding? Check if each child has the understandings listed in the top part of the Term 1 scope and sequence. The following assessments could be used. As a subscriber to a Learning Place, a Teaching Place, you have automatic access to primary maths, where you will find questions similar to the questions above to assess student understanding across all concepts and all levels.